So we need a common denominator to add these fractions together. This term needs an x plus 5 on the top and bottom to equal 1, and this term needs the x plus 4. And as I rewrite my fraction, I'm going to distribute this x and the 5. So we have x squared plus 4x divided by the common denominator plus 5x plus 25 over the common denominator. Because my denominators are the same, I can add my numerators. 4x plus 5x is 9x. And I'm going to leave my denominator. Does my numerator factor anymore? Anything multiplied 25 that adds to 9? No, so this is my final answer. I'm done. Now for b, my common denominator is going to be 2x plus 1 times x minus 3. So this term needs a 2x plus 1 on the top and bottom. This one needs the x minus 3. And I'm going to be extra careful because it's a subtraction problem. I'm going to change this to be adding a negative 2x. So that when I distribute my 4x, and I'm going to distribute a negative 2x. And that's all going to be over my common denominator. 4x squared minus 4x squared is 0. Negative 12x minus 2x is negative 14x. And that's my answer. To simplify complex fractions, I first need to get my numerator as one fraction and my denominator as one fraction. So this needs a common denominator of 3, where the denominator needs a common denominator of x. So in my numerator, I'm going to have x minus 12. And in my denominator, 5x plus 1 over x. So now that each numerator and denominator is one fraction, I can multiply by the reciprocal of my denominator. Nothing simplifies, so as a final answer, I'm going to write it as one big multiplication problem. You could distribute the x and the 3 if you'd like, or you can leave it in this form. Before I start adding d, I'm going to factor this first denominator. And it factors to x plus 2 times x plus 2. Which means this second fraction, to get a common denominator, just needs one other x plus 2. So here we get 5x plus 10. So we have 2x plus 3 plus 5x plus 10 over x plus 2 times x plus 2. Simplifying my numerator, 2x plus 5x is 7x, plus 3 plus 10 is 13. And that's my final answer. Now for e, I need a common denominator in the numerator and a common denominator in the denominator. So in my numerator, I need an x plus 3 on both. So that gives me 7x plus 21 plus 5 all over x plus 3. And I'm going to rewrite that as 26. And then for my denominator, the multiple of x plus 3, the product of x plus 3 and x minus 4 is my common denominator. So this one needs an x minus 4 and this one needs an x plus 3. So we get 9x minus 36 plus 8x plus 24. So simplifying that, 8 plus 9, that's 17x minus, now negative 36 plus 24. Again, it's non-calculator, so if you need to do some scrap work, I mean negative 12. My numerator stays the same. I haven't done anything to that yet. And now we can multiply by the reciprocal of our denominator. So that is going to give me 7x plus 26 divided by x plus 3 times x plus 3 times x minus 4 divided by 7x minus, or 17x minus 12. These x plus 3's can cancel, and my final answer is 7x plus 26 times x minus 4 over 17x minus 12. Now for solving, I can cross multiply for a. That makes this one's easiest to cross multiply. So negative 2 times x plus 1 equals negative 8 times x minus 1. Distribute the 2, distribute the 8. I'm going to add 8x to the left. I'm going to add this 2 to the right. 6x equals 10. So x is 10 over 6, which reduces to 5 over 3. Now, checking for extraneous roots, we cannot divide by 0. So if I plug 5/3 into either x, does either denominator equal 0? No. So my answer is 5/3. Now for b, I'm going to cross multiply again. So this side we need to multiply together. This equals negative 3x. And I'm going to move everything to the right-hand side so I have a positive x squared. So we have x squared minus 2x minus 35 equals 0. What multiplies to negative 35 that adds to negative 2? Is negative 7 and positive 5. So x equals 7 or negative 5, but I have to check both in here in the denominators. Neither make a denominator 0, so both are the answers. Now for c, I can't cross multiply because this side isn't one fraction. But if I make every denominator x minus 2, I can set my numerators equal. So I get x squared minus 2x plus x equals 2. Distributed this x. Well, that's x squared minus x minus 2 equals 0. And that factors. So x equals 2 or x equals negative 1. But when I plug 2 back into my denominator, I get 0. So that's extraneous. It's not an answer. My only answer is negative 1. To match these graphs, I'm going to look for my asymptotes. For A, the vertical asymptote is at x equals 3, and the horizontal one's at 0. For B, again, my vertical asymptote's at 3, but my horizontal asymptote's at 1. For C, my vertical asymptote is at negative 2, because that's what makes the denominator 0. That was the case for all of these. The degree of my numerator and denominator are the same, so I divide the coefficients for my horizontal asymptote. Same thing here. 2 makes the denominator 0. The degrees are equal, so my horizontal asymptote is at 3. 3 divided by 1. So let's see. This is 3 and 1, so that's B. This is at 2 and 3, so that's D. This is at 3 and 0, so that's A. And this one, let's make sure it's C. Negative 2 and 1, that's C.